because right now I only see the silhouettes. So if you want to wear an angry face, you can do it. Feel free to have all the facial expressions you want, because when it's dark in the room and the lights face the speaker only sees the faces on the first row, and it's good when the first row is taken by the fans of the speaker. And so if you're scared to come to the stage and become a speaker, don't be. You don't see the people anyway. It only looks like Zoom when only a few cameras are on. So, if you're ready to welcome the next speaker, from Yandex, Anastasiia Abrashitova. Nice time. The first slide says that you're going to talk about love, but yeah, it's something professional. And my first question is to you, because I'm not allowed to ask questions here, so I'm using this moment. Are you okay with your work and life balance? If you're going to talk about love that's in your work life.
Yes, there are different lives. In my life, there is personal life, and in my personal life, I am in love with my family, which is very supportive, and I'm obliged to say this because they overheard some of the dry runs. I also have my friends who have been with me more than half of my life, and they are a big part of my life too. And when I'm at work, when I'm the head of repository tools, I'm in love with monorepo. So I'm pretty balanced, I guess.
So we start to talk about love on high load.
Well, hi. My name is Anastasiia Abrashitova. That's the international version. Or you can call me Anastasiia, because we are here in Belgrade, and I've been living here for half a year, and that is how I'm called in Serbian. Or you can call me Anastasiia or Nastya. That's the name my parents gave me all those years ago in Russia. But we are at an international conference, so let's stick with Anastasiia. I'm the head of repository tools in Yandex. It means I'm obviously responsible for the repository and for most of the tools I'm going to speak about today. I'm also a big fan of public speaking, and I did a lot of talks in Russian. But it is the first time I actually do a talk in English, so I'm a bit nervous and it does me no good. Please be fair with the marks you put me after the talk. I really need your feedback because I need to understand how well I did in English. I'm an amateur organizer of events, mostly about infrastructure, because that combines two loves of my work life. And I also have a channel. It is in Russian. It is called Записки с горящего дома, or Notes from a Burning House. It is about management and leadership and a bit of soft skills in IT. And of course, as you guessed already, I am a person who is deeply, madly, absolutely in love with monorepos as a concept, and with one particular monorepo we have in Yandex. So, how does one actually make a monorepo? Well, it is pretty simple. First, you take all of your code, then you put it into a single repository, and you call it monorepo. Voila! You've got a stockpile of code, all your tools like IDE and VCS are lagging, your developers really, really hate you, and you've got nothing out of it, no profit. Obviously, it's not how you make a monorepo, so today we are going to talk about how you actually create one. And we will start with the questions like, why? Why do we even need it? Or is it even possible? And then we will talk about how you make your developers collaborate, because that's a bit of a spoiler for the first point. And then we will talk about the tools you need in general, and the ones we have in Yandex. And in the end, I will talk about if it is really worth it, just a little bit. So, what for? Well, first of all, your company probably has a lot of code. If it is old, or if it is big, it probably has a lot of code, like a huge mess. And what it totally doesn't want is you to rewrite the code once again. Because we know that every developer, for instance, wants to create his or her own JSON parser. If you leave them unattended, you will have a bunch of JSON parsers. But the goal of the company is to prevent that. It wants you to reuse the code you already have and save your time. And maybe make the shared code better, faster, more efficient, maybe more robust. But it definitely doesn't want you to simply go and write this code once again. And to promote this sharing, first of all, you need sharing basic tools, basic utilities, basic libraries. And you need to have shared ownership in them, so that everyone in the company will feel a bit responsible for this basement you have. And another way to promote sharing code is to promote the code from different projects. So your project, for instance, needs some code that another project has written, and you just take it. You don't copy-paste it, and you don't take ownership. You just use the code your neighbors have written, and they still support it, but you are allowed to use it, and that is code utilization. Another thing a company probably wants is up-to-date dependencies, because stale dependencies are really, really bad. If you have a dependency that is stale for a major version, perhaps you need a task in Jira to update it. If you have a dependency that is stale by several major versions, you probably need an annual goal. It is a big work, and it sustains itself. After you've waited for some time with updating your dependencies, the work to update them becomes so huge that you start staling just because you don't have the time to update them. And because of that, the dependencies go older and older and older. And if your dependencies are internal, you use a library that your neighbors make, and you don't update it quickly. Let's say you update it once in every 3 months. So you tried updating it, and you discover a breaking change. They did something that you are not compatible with, and it would take you a long time, a big effort to become compatible. So what do? You come to this team that makes the dependency, and you say, hey, do you remember that pull request you made 2 months ago? Well, could you please roll back? And probably you can guess the answer they will give you, especially if this version of the dependency has been integrated into every other consumer. So stale dependencies are bad. And in order to prevent that, you need to update quickly. And you need common branching policies. At least you need fresh dependencies in the trunk, because it is usually doable. And especially it is doable with TBD, trunk-based development, because the idea of trunk-based development is that everyone commits into trunk quickly, and everything is checked and is compatible. You also need some common CI, because you don't want to roll back these breaking changes. You want to prevent them. And to do that, you need your team that makes the dependencies to have a shared CI with the dependent team, so that they make a pull request and they see that your tests are broken, they're red. But we know that not everything is caught by tests, so probably we also need frequent delivery, so that we could find all those problems that only emerge in runtime. Under high pressure, under frequent usage, some problems emerge, so you need to deliver frequently. And one great thing to do all that is dependencies by code. You all simply live in the same branch, like trunk, and you simply take your dependency as a code, not as a binary, not as a library, as a code. That is possible because of monorepo. And the third thing that monorepo allows is knowledge sharing. The company has spent a lot of time, effort, and money to hire the best engineers it could. And of course, it wants you to share your knowledge and become better versions of yourselves. And one of the ways to do that is to use code search, because usually developers speak in code. Your way to speak to another developer is just to go and read their code. And in a monorepo, you could find a lot of useful code. You just need to write something, you go, you search, and you find how it is done in your company with your components and your code style. Another thing that monorepo allows you in knowledge sharing is really understanding your dependencies. Because sometimes understanding the interface or the documentation is not enough. You need to know the behavior in depth. And to do that, the best way is to just go and read the dependencies code. And of course, you could do that in monorepo. And the last thing is about common code. This common code is the basement of every project your company does. So usually it has some top-level developers as maintainers. They look at pull requests, they do code review, they answer questions. And committing into that common code is a great way to share knowledge with them, and they are really good. So, a lot of good possibilities, but is it really possible? Well, let me present you Arcadia, Yandex repository with 26 years of history. 26 years, it is probably older than some of you. No offense. It is really old. It started as the monorepository of Yandex search engine. And for a long time, it was all there was in Yandex. But then different projects became to emerge, and they had different repositories, different infrastructure, different languages. They all were separate. But 10 years ago, our late CTO and co-founder, Ilya Sigalovich, made a decision that we need a common infrastructure. We need common development tools, deployment tools, and monitoring tools. It was called Project Unity, and 10 years here is literally 10 years, because we will be celebrating the anniversary in 2 weeks from now. We'll have a big party, because I believe we succeeded in his ideas. Well, it is nowadays home to most of Yandex services, not all of them, but almost all of them. And probably most of those you know, like search, obviously, market, taxi, Lavka, browser, etc. It has 10 terabytes of code with history. It takes more than 21,000 commits per week. And it has more than 6,000 weekly users, which is pretty huge for an internal tool. So, it is possible and it is good. How do we do it? Well, as we talked earlier, it is not enough to put all the code together. You need your developers to collaborate. How do you do that? Well, first you enable them to do it. And the first step you take here is to limit the complexity. First of all, you need to limit programming languages you have in your company. Because reading a code in a completely different language or in a completely different coding style is difficult, and reusing this code is difficult too. So people will avoid them and just reinvent everything you already have. So you need to limit. For instance, we have only 5 languages for backend development. That is C++, Go, Python, Java, and Kotlin. Kotlin is the most recent we allowed. We also have common styles and common linters, so that it will be really easy to go and read another developer's code. You also need common toolchains and frameworks, and everyone who tried to combine 2 libraries written with different libc in the basement knows how important it is to have a shared toolchain. And we have shared open source dependencies, because as we know, every developer wants to write their own JSON parser. And every developer will try to introduce their favorite open source JSON parser. So in order not to have 1,000 of those, you need to limit. You need to have some group, some committee that will say, hey, we already have an open source code for this. It is right here. It is in no way worse than the one you are offering, so please use that. You limit the complexity, and it is easier to understand other programmers' code. Then you start with the rules. And the basic rule is that everyone is allowed to commit everywhere. That's scary, right? Well, everyone is allowed to commit everywhere as long as the tests are green. That is our philosophy, that every project in monorepo is responsible for writing the tests for their code. So if something fails in production because it was not caught by the tests, we usually roll back, of course, because, well, we are all collaborating and we are no enemies to those who depend on us. But we usually ask them to make a about writing the tests, because every breaking change should have been caught by a test. And also you can introduce code review. If you are really scared that someone will break your business logic or some complex things you've done, simply introduce code reviews, but be sure to review quickly, because long code reviews, when they're huge and they target different places in monorepo, those are bad. So be sure to do code reviews quickly. And then you start building a culture, so they can work together. Now you should ask them to. And this culture is built from top to down. First, the managers, the high levels, start saying things like, hey, please do not reinvent anything here, we already have that. Then it goes down, it goes to team leads, and finally it reaches the developers, and everyone knows that you should reuse the code. Also, you could make your common code, that basement we have, an inner source. That means you need to abolish ownership there. There should be no team that is responsible for doing tasks and making features in there. It should be really shared. Everyone should be responsible. And if someone needs something, they should just go and do it. You don't have owners, you have maintainers. Those who overlook it, those who understand it, those who do pull requests, code reviews, but they are not those who own. And of course, you cannot build this community without allowing everyone to participate. Decisions like common coding styles should be decided not by some programmer in the infrastructure team. They should be decided by the public, by the developers. So you introduce something like a committee of top-level experts on some technology from different parts of your company, and they make a common decision how things should be done in their domain. Well, another thing I told you in the beginning will get your developers really, really angry is slow tools. Of course, that depends on how many code you have, and for small monorepositories, it is possible to just use some things that are available on the market, in the open source, whatever. But for really big repositories, of course, the companies start inventing their own. And today I will tell you a bit about the tools we have in Yandex. And I will start with Arc. It is a large-scale centralized VCS based on file system virtualization. It has more than 10 terabytes of data, as I've already told you, or 240 gigabytes of data in the trunk version. And it accepts more than 30,000 commits per week. It is serverless, it is stateless, and it supports horizontal scaling. That means if your servers stop coping, you just add more of them, and they just work. Of course, there is a downside to it. It means that you need to always be connected to the server. You cannot just go and edit your code on a plane and expect that everything will work fine. Well, it won't. You will have to do some changes manually. It's also based on virtual file system on the client. It means that not all the monorepo is downloaded on your hard drive. Files are listed and downloaded only when they are needed. So when you browse some directory, the list of its contents is materialized. When you look into a file, its contents are brought to your hard drive, are materialized, and you can look into it. Of course, our own VCS allows us not only to be fast and scalable, it also allows us to have our own scenarios and flows. For instance, we started with copying the Git flow, more or less, the commands from Git, because everyone knew them, and it was pretty easy. And a few years later, we realized that maybe it is not the only possible way, because Git flow is just the way it is. It is just accepted by everyone, but it doesn't mean that it is really the best one possible. So we introduced another flow, a simpler one, where you don't have to really understand the difference between rebase and merge and what goes on under the hood of your VCS. You can just say, hey, I'm starting to work on a task. I need to update from the trunk version. I need to see what files I'm going to commit. OK, create a pull request. And that's actually all you need. And updating the pull requests, of course. And we also know that not all tools allow you to introduce some plugins for a separate VCS. For instance, Xcode doesn't support any plugins. And for those who have to use Xcode, we introduced Git shards. A Git shard is a subset of your monorepository, some folders you specify that are exported as a Git interface. And you can use them through Git, and everything will work, just as if you had a small Git repository, and everything will be committed back into Arc. Well, if you had your own VCS, you need your own portal for developers, for code reviews, for code browsing, and for search. And that is Arcanum. It is the CI/CD interface for the whole monorepository. It is the interface for code reviews, so you review the pull requests, you write your comments or your issues, you say it's fine, ship it, or it's not fine, block it there. It also supports code browsing with navigation, and it is very important in the monorepository, because as I told you, every time you look into a file, it is brought on your hard drive. So you don't want to look for something in the entire repository and have it all downloaded on your hard drive. Instead, you go to the web portal, you search there, you browse there, and you use the code navigation we have provided there. It has also some data, some statistics like performance insights for developers, for teams, all the data that we have about our repository. We can aggregate it, we can give it back to people so that they could find some insights on their performance and find ways to improve. And it is pretty heavily loaded as well. It takes more than 10,000 of pull request iterations every week. Another thing we had to do in Yandex is our own build system, Yamake. Because our main language was C++, and because of code dependencies, we have huge build graphs. Because instead of depending on some binary, you start depending on the code of this binary, which has its own dependencies. As this graph, this dependency tree, gets really, really large in the monorepository. And there is a configuration stage in the build when you need to build this graph, and you need to find all the commands you need to actually do to build your target. And that is not really fast in CMake. It was taking a lot of time, it was unacceptable, and there were no alternatives at that time, so we wrote our own build system. It is called Yamake. It makes more than 3,000 builds per week, and it has more than 250 build modulars in our monorepo. It has a distinct, scalable configuration stage. That means you can not only scale it and partition it, you can also reuse this graph, these results of the configuration. It also has good language interoperability, because we have limited our languages. So we know exactly what languages our developers are going to use. And because of that, we are able to provide really good interoperability between these languages. It is a really narrow subset. It is cached. Of course, it has both a local and distributed cache. And most often, when you build something, you take most of your dependencies from the distributed cache. It has some things we needed in Yandex, like dependencies check or licenses check, because we need to check license usage in our programs. And also recently we introduced the possibility to export our build system into different build systems like CMake, Gradle, requirements.txt for Python, no, but builds Python actually, except us. We did that for open source projects because we are exporting a lot of our projects to open source, so we needed to support some common way of building those. And the last thing we did for monorepo, the last tool, is AutoCheck. It is a large-scale CI system which does both pre-commit and post-commit checks. It is really repository-wide, so if you change something, everything that depends on this bunch of code, including transitive dependencies, is built and is checked with tests. We need 2 tests for each commit, pre-commit and post-commit. The pre-commit test is the one you do in your pull request to make sure everything is green. But we don't have a merge queue. Our commits do not queue one after another. So while you check one of your pull requests, a lot of other pull requests are checked, and some of them are landed into the trunk version. And maybe when your commit lands, it is already not green, it is broken. So we need to make another change, the post-commit check, to make sure everything is green in the end. It uses a large distributed build cluster with more than 120,000 of CPUs, and it produces and stores more than 1 billion test results every day. And it stores all of them, all the test history from the very beginning for eternity. And of course, with such rich test history, we can also provide the detection of flaky tests, of failing tests, so they don't actually come out randomly and make your pull requests red. Well, the final question, I promised you, is the question if it is worth it. Okay, let's start with code reuse, I promised you. We have counted the weighted average, and we have discovered that our projects have more than 23% of outer project's code. That means their neighbors' code they are using. And they also have almost 45% of common code, including open source, of course. That's why the numbers are so large. Code search. Well, each day we have 58% of our developers using the code search. And of course, they don't need this web-based code search if they're searching in their own projects, because they have those downloaded on their hard drive. They just search in IDE. That's why if they search for external code. They search throughout the monorepo, and that is a way of knowledge sharing. And dependencies. Well, more than 10% of our pull requests have failures of the tests that were not in the project that was originally changed. That means that 10% of the pull requests discover breaking changes in their dependencies and prevent them from actually breaking something. Well, that's actually everything I wanted to tell you today. Once again, I will try asking you to please rate my talk in the app or on the web. And I'm welcome to your questions. For the best one, I promise you this wonderful fella. We need someone with a microphone.
Hop.
Okay.
Hello, I'm your coworker. I know about monorepo, but I know what the monorepository is expensive because you need support some tools. That tools are not open source, etc. From which company size do you think is it profitable to have a monorepo?
Well, it is profitable because of these numbers. Because the team that makes those tools is not actually that big. For example, Arc is made by the team of 4 people who are all sitting in front of you. And we don't have that large development team. And open sourcing our projects, it would be not profitable. It would be maybe a good deed for the world, but it will bring us no profit because there are no large demand for our tools on the market because they are intended for large companies. And large companies usually have some of their own tools. They have their own infrastructure department. And our team is small enough so that these amounts of code reuse would be more profitable than our salaries.
Running with the microphone. Yes.
Hello, 1, 2, 3, 1, 2, 3. Thank you for your talk. Yeah, I have a question about how to avoid dependency hell, because if we encourage people to reuse code to search already written solution, this makes me to think about that every my class could be reused by someone, and if I make a change in class that I don't want it to be reused, it could break someone's code. And yeah, this is two questions, I'm sorry, but they are interconnected between each other. And how to avoid the situation when my project depends on many other models, I cannot just make it commit before test, because I need to rebuild every time, while others keep committing to models that I reusing.
Okay, there's two questions. I'll try to remember them. Well, the second one, you usually do not commit into a lot of your dependencies at the same time, because, well, this is TBD. You need to change something, you usually change it in just one of your dependencies. The situation can be vice versa. You have a project that a lot of people depend on. And if you change that, you make a breaking change. You also need to change everyone who depends on you. That is a problem, of course, and there are just two ways you could do it. First, you could do it quickly, just hope that everything will be okay, and if something changes while your pull request is still reviewed, well, you will update your pull requests. Of course, you will lose just a bit of your time. Most of our developers don't encounter it unless they are the ones working with this common code, shared components, open source, things like that. And another way is not to do the change breaking. So you just, for instance, you need to change the interface. You make the work and you introduce the new interface without losing the old one. Everyone is still using the old one. One by one, you change your dependencies, your dependent projects, so that they use the new interface, and then you remove the old one. And of course, I forgot the first question.
Yeah, the first one was, basically it was about controlling of dependency between projects, but you kind of answered on it.
Okay.
Yeah, thank you.
Thank you.
Thank you.
Please.
Hello, Anastasiia.
Hello.
Thanks you for your awesome presentation. And could you describe in details about code search future? I mean, what options it support? I mean, how I can find some implementation in monorepo in case when I don't know any functions, names, and models, and so on. I mean, it's not just a grep, just stupid grep.
Well, of course, you cannot do that unless you know what you are looking for. So the code search is actually just the search based on some wildcards. So you look for the exact match. But if you are looking for some common component, you could just look at some documentation, what we already have, or you could probably ask some of your colleagues. In the worst case, no one will tell you that there is a component for this already in the monorepo, and you will not ask enough, and well, you will write it once again. Sometimes it happens.
Thanks. And I have a second question. How many times it took for merging pull requests on this monorepo, which I should wait when all tests will pass if I make little change in single model?
Well, most of the times, people who work with the monorepo actually work with the end targets. For instance, they work with some programs, not the libraries in the basement. So their pull request is a very common one. They just change their projects. The problems arise when you change something in the basement. And that depends on how you do it and if your change is a breaking one. So the best way not to have to fix other people's code is not to make breaking changes. You just do something, but you don't break.
Thank you.
Hi, thank you, Anastasiia, for your talk. My question is about the last line in your previous slide about 10% of failures in outer projects. So let's suppose I'm a programmer in one of the projects and I make a pull request which make some error in outer project tests. So can you share in a little more details what will be in that case? Who will fix the tests? Who will review it and so on?
Well, most of the times you are responsible for your tests being green. So if you are changing a library and some consumer of this library fails, you go and you fix their code. That is the idea of monorepo. So since you can commit everywhere and you need your tests to be green, you go and you fix their code. And actually it is usually faster and more convenient than asking them to do it, because they will tell you that they need some time to do that. They will start planning. They will tell you they will put it into the next sprint, etc., etc. It will take you a week or something. So usually, as a representative of a team that does change a lot of things in common components, usually we just go and fix these things ourselves. And sometimes we ask the projects to help us if we don't understand what is going on there, because we are good developers, but not that good to understand the whole of the monorepo. And sometimes the changes are too huge to be fixed by a single team. For instance, I have a team that is responsible for open source code brought to Yandex. And if we do something like changing the version of C-lang used in Yandex and also changing the version of C++ standard to introduce a new one. And you have a lot of problems that arise from new checks, new warnings, new errors that a new compiler and standard bring. Then I ask the public to help. We have a mechanism which is called crowdfunding, thank you. We have a mechanism that is called crowdfunding. It is the mechanism when we come and we say, hey, we are doing this, like we are updating a C-lang, we need 10 days of help for that. And people just come and donate a day or two maybe. And when all the 10 days are donated, we just come to people and ask them to spend a day working for us, and they do, because the monorepo is a collective effort, and everyone, every C++ developer needs a new C++ standard. That's why they cooperate, they spend some time doing that in each other's projects, not just their own, throughout the whole of monorepo.
Thank you. Please.
Thank you for your presentation. One more question, just a bit more about collaboration between different teams. You have a lot of developers, and let's say one development team created a JSON parser. Okay, how another developers know about that? It's only documentation, and that's all?
Usually when a developer creates something that he believes or she believes to be good and reusable, they want to share it. And they just want to share it themselves. That's why if it is a JSON parser that is a pretty common utility, they will probably want to put it into some shared code library. And if they will be allowed, if the maintainers don't tell them, hey, we already have 3 of those parsers already, they will commit there, and every developer actually knows what the utility functions are. He or she can just look through them and find the one they need.
Just a second, and if it's just a JSON parser, it's okay. Developers understand that it's a common feature and they can spread it. But what if they made something for business processes and they don't know that this code can be used in another business processes?
Well, if you have created something good and you do not know that someone else needs it, it's actually not your problem. It is the problem of the person who needs it. So when you know that you need something, and that is something not trivial, you probably start thinking where I could find something like that. For instance, we needed a good scheduler for our distributed build system, and we started thinking what other teams in Yandex probably have schedulers for some large clusters. And the team went through a few of their colleagues, other teams, asking them what schedulers they have and how they are developed. And they chose the one they want to reuse. They actually asked for permission because they will be dependent on that heavily, and that is a huge chunk of code that will become harder a bit to develop because you will have breaking changes from that side. And they just reused it after that. It is not a common component because just 2 teams use it and it is very specific, but they reused. And it saved them about a year of development, I believe, because it's a pretty complex scheduler.
I'm not sure if you like it, but we have 30 minutes until the next talk.
Okay.
So we'll get on with the press conference. Please.
Yeah, hi. Thank
Hi.
you for your presentation. My question regarding limitations for limitations of languages and code style, but you mentioned only backend languages. So Yandex have really, I think, huge data code base of frontend. Do you have something for frontend or not, and why?
Well, those language limitations are actually the language limitations for Yamake. They are for the core of the monorepo, the one where all these tools are applied with the common CI/CD. And that used to be mostly about backend. We have made a few efforts to create a front-end monorepo. They emerged and they failed with some time because it got huger and huger and it failed sooner or later. And nowadays we have a project that integrates front-end builds into Yamake. So nowadays Yamake is actually capable of building front-end code. And they reuse all of these tools. They reuse AutoCheck. You can create a change that simultaneously changes your backend and your frontend. You could create a change that changes your protobuf spec that is shared between backend and frontend, and you change them both at the same time. It is possible. So we are looking to share the technologies we have for backend in frontend, and I believe that this project, it is new, but it is rising pretty quickly, and I believe that that will be the way for Yandex frontend in a few years.
Young man from New York Times, please. Yes. No, it's a joke. Your question, please.
Thank you. Hello. First of all, my name is Sergey, and I also in love with monorepo, but I have such question. For example, I'm a single developer. I'm working on some library that becomes widely used all over the projects. And I introduce an experimental API for this library. So old one is working and everyone are using it. Time passes, new API becomes more popular, more developed, and I feel that it's my technical debt to remove old API completely. But I can't do it myself because it's a huge work. So can any developer just ask everyone else to contribute? It's not a C++ or C-lang update. It's something small, but very important.
Well, first of all, I don't understand why you will be removing an API that everyone is using. If they're using it, it is good. If it is good, don't remove it.
It's not good enough, and it forces me to use old architecture. I can't refactor, I can't implement new features.
Okay. Well, this is the point where you either create the change, if you are capable, or probably you start talking to the people who use your API, and you find some core teams that are interested, most of all, in that API because they're using it heavily, and you go and you talk to them. Maybe they will help. Maybe they will move out. Maybe they will ask you to just fork, please, leave them a stale version. You will try to resist, and maybe you will succeed, maybe not. And then they will take this component not as a shared one, but as their own with some legacy, and later they will deal with this legacy. So there are a lot of options, and unfortunately, if you create a common components, you do have to deal with people.
How many questions are you ready to take?
I could do this all day.
Okay, please.
Hello, Anastasiia. Thank you for your talk. I work with monorepo too, but at Fivetran we have one product. And you said that all your products live in one repo, and given that we are in 2023, how can you possibly handle the situation where, in example, taxi got split from Yandex or something like this, where you need to split your products?
Split them because the companies are splitting?
Company split, yep. Like there is a Yandex and there is a taxi. Now it's different companies. How can you possibly handle that because they are too dependent?
Well, Yandex and taxi are not two different companies, thank God. Well, when some project moves out, for instance, we had Zen and News moving out, we start with building the graph of all of their dependencies, and we'll try to understand what they depend on. So probably because it is monorepo, it has huge dependencies graphs, it will depend on something like the engine of the search, transitively. Obviously, you cannot let a team move out with the engine of your search. So we start cutting out the dependencies, replacing them with something, or maybe copy-pasting some code because they don't need the engine. They actually just need some functions from there. And when we are sure that all the dependencies are cut out and we are sure we can give away the things that the project depends on, we just copy them to a single repository and we leave them be.
Thank you.
Okay. Hi. Thank you for your presentation. You've already told that it's not worth to make it open source. But what if we're talking not about open source, but some kind of paid solutions for other big companies like SaaS or on-premises? It would be great for some people.
Well, I didn't actually say that it is not worth. I told there is no economic value in open sourcing it because, well, the effort to open source will be bigger than the contributions we will get, probably. We are thinking about maybe open sourcing our tools, and what we are trying to understand is the demand. So this is software for large companies. You don't need that if you have a small company, because these things will just lag you a bit. They are architectured for big scale, and for something small, they will be just having too much, too complex logic, too much initialization time. You will just lag. So only big companies probably are interested in those, and big companies are usually, well, just a bit paranoid about security. They are not ready to use cloud solutions. They are not ready to store their code in the cloud. They want something on-premise. So it becomes like a box solution that you need to put a lot of effort into creating so that it would work in every environment. It would work with different operating systems or something. And after that, the worst thing you could do is discover no one actually needs it. So what we are doing now is trying to discover if there is need, if there is interest for our tools in open source and as a paid solution and as a cloud solution. Those are three different options. And if you have some interest, please come to me. You have all my contacts here, or you could just come to me in person and talk to me. Because if we see that there is really need for our tools, we will probably open source them just to share them. We are not greedy, but we are not sure there is demand. It would take a lot of work, we have counted, estimated.
Please.
Hello. Oh, it's working. So thank you for your presentation. I wanted to ask about I want to ask about what if I want to build something on my local machine or test something on my local machine? So you said that I can't code on a plane because I'm always have to be connected to the server. But so this leads to the problem that I don't have all code, for example, for build my web application and test it or run it with debugger or something else. How do you deal with that?
Well, of course, you have all the code you need for your project, because it is probably not the entire monorepo. It is just the code of your project, and your project is small enough to be stored and tested locally. For those who are too big to be tested locally, like I don't know, YDB as a whole, we also have the ability to use these large-scale build cluster we have. It is mostly for auto-check, for automatic CI/CD changes, but you could also build it locally. You just say not yamake on your machine, you say yamake minus dist, and it started building both locally and in the cloud. Which one comes back faster? That is your result. So if you need some large-scale build, you could reuse the build cluster.
But how it deals with all the dependencies? It somehow will download all the dependencies to my local machine.
Well, if those are your project's dependencies, then of course you download your project with all the dependencies it has. So when you start making it, you download all of it.
So I can select all manually. It won't be handled by your monorepo. Which directors will download to my machine?
Well, it will be handled by the monorepo. There are two main cases. First one, you just start building from the command line. So whenever your build system tries to access some file, it will be downloaded automatically because of the virtual file system. So there is no difference if those are already on a hard drive or if they are not, because it will see no difference and it will download. And another way is if you want to work with your project in an IDE. If you work in an IDE, you probably don't want the IDE to see all of your code, because you may have a lot of code materialized on your machine and a lot more code in virtual file system. That's why we have special command line utility that builds you an IDE solution if you want to work in an IDE. For instance, you say that you want to work with this project in PyCharm. It creates you a PyCharm solution, you open it, and you have your project and its dependencies and nothing else. You can search, you can browse, everything's fast.
That's interesting.
Thank you.
Thank
Guys,
you.
this is a free country, so if you want to stand up and leave to the expo, please do. But we'll continue with the press conference. Please.
Hello, thank you for the talk and for this long question and answers session. One of the main advantages of monorepo is that everyone can contribute in everything. So, for instance, YDB, great database, and once it becomes open source, is there a process how to maintain it inside and outside the company? How is it organized? Is there a possibility to save this advantage to contribute from inside?
Well, it is a pretty complex process. I mean, there is a service that syncs code from internal repository from Arcadia to GitHub, and there is a service that syncs back the pull requests that people bring to open source. I will not go into the depth because I already gave a talk on that on one of the previous high loads in St. Petersburg. So you could just look for my talks on high load, you will find that one, and it is a long talk about how we open source things and work with them.
Thank you. Please, we'll take 2 more questions and then figure out where does the duck go.
Oh, yeah.
Okay, so my question will be about merge trains. You told there are no merge trains, and do you have an option to lock a repository from commits for everyone? For example, if you need to make a really major breaking change, so you have 30,000 commits per day, that means every 3 seconds someone commits everything, and if we have a merge request with something really breaking, that means that every minute someone will commit conflict.
No, if we need to do something like that, first we will start to do it the TBD way. That means we will start to put everything we can commit into trunk without breaking into the trunk. Then we will probably start doing something like a parallel interface, as I answered already. So we will try to introduce both the possibility to use the old way and the new way at the same time. And we will start gradually switching dependencies from the old things to the new things until everything is switched to the new one, and then we will turn off the old one. For instance, if we have a very complex update of an open source tool, we may do it that way. We may put both of them into the monorepository, gradually switch projects from one to another, and then remove the old one.
And the final question for today.
Hi, Anastasia. Thanks for this presentation. Thanks for this Q&A session. That's very interesting. My name is Ivan, and I have a question. Yes, you mentioned that you supply tool chains within your monorepository, and also you mentioned that you sometimes upgrade your tool chain, like change CLN version or something else. And I have a question. Do you have some politics on tool chain deprecation? Like, do you only add new tool chains, or you have some politics to remove something very old, like you say, okay, we stopped using C++ on 98 because it's too old?
Well, it actually depends on the language. Of course, we have some policies to remove all tool chains because otherwise it would be impossible to live with this complexity because additional tool chains introduce additional complexity. In most languages, we have a single version of the toolchain. Like Clang, we have just one Clang we use. And if we want to update it, the team that is responsible for that, the team that is responsible for open source components from the external world, they will try to update the whole monorepository to the usage of the new one. So probably first they will introduce a new Clang, they will bring it, we also build Clangs, as well as we build everything as a dependency by code. So they will bring a new one, they will put it into the new repository, the monorepository, and then they will introduce it with all the breaking changes turned off, like all the warnings turned off. And then they will start gradually switching on the warnings and fixing everything that breaks if you turn them on. Because a warning is actually treated as an error in our environment. That is a complex project. It may take a month or two. That's not easy on this scale.
Nice, thank you very much. It was powerful.
Thank you. Please don't grade. Don't forget the grade. I need the grades. I need your feedback.
And now we have two souvenirs. One is your beautiful duck.
Oh, I wanted to give it to the person who asked about open source.
If you could wave if you asked the question.
Who asked me the question about open source and YDB? I think this person left. Then I will give it to the person who asked about tool chains, because I like when people hit into a large bunch of work we do.
If the person's here.
Yes, I believe no one left from there. Yes,
oh, there he is.
Person.
Okay.
Here is your goose.
And we also need to pick one more question.
One more question. Okay, I believe we had a good one there. Let me see. About how you work if you have a lot of things depending on you. But yeah.
There he is.
Oh, okay.
Thank you. So you also get a souvenir for a good question. Thank you very much.
Thank you.
Thank you, Nesta.